This is the fact file 4.6 Isomerism for the CCEA A-Level Chemistry course, and these are the answers to the fact file questions. So question 1, which one of the following does not contain an asymmetric centre? So I've just drawn out the first one here, and you can see 1, 2, 3, 4 carbons, and on the second carbon we've got a methyl group coming off the second carbon. But if you look at this, that methyl group is effectively the same as the other CH3 attached to the carbon, so there are no asymmetric centres there, and that means that A is the answer. If we just check the other ones, all of them have 4 carbons in a chain, and they all have something, either the Cl or the OH or the NH2 attached to the second carbon, and that means that this carbon here actually is attached to 4 different things. 1, 2, 3, and the hydrogen is 4. So B, C and D all do have asymmetric centres. A is the only one that doesn't. Question 2, which one of the following displays optical isomerism? So again, we're looking for a chiral centre, an asymmetric centre, and looking at this, which one does display optical isomerism? So it has to be this one. Looking at this carbon, we have 1, 2, 3, 4 different groups around it. All of the other carbons have 2 groups the same in this, or only 3. So yeah, okay, so it has to be, for this one it has to be A. Now question 3, 3-hydroxybutanol, and it gives you the formula there, is optically active. Explain the term optically active. What I've said is it contains 2 optical isomers or enantiomers, and each will rotate the plane of plane polarized light in a different direction, or you could say in opposite directions. And draw the 3-dimensional structures for the 2 optical isomers of 3-hydroxybutanol. So I've drawn it out here. 1, 2, 3, 4. That's my butanol. So the carbonyl group here, and it is 3-hydroxy. So 1, 2, 3, and there's the OH group attached there. So looking at this, then we can see that the chiral centre is here. I've got 1, 2, 3, 4 groups around it, so that's my little chiral carbon there. When I draw it out, you can see I have the OH at the top, methyl group here, hydrogen here, and then the CH2CHO there, and then just doing the mirror image, you see the same 4 groups, but in the mirror image orientation. Okay, 3-hydroxybutanol may be dehydrated to form but2-enal. Suggest a structure for but2-enal. Well, there's only one thing really it can be. You've got your aldehyde group here, and then it's a 2-ene, so it's on the second carbon. And there are a number of structural isomers of C4H9OH, however only one has an asymmetric centre and can exist as an optical isomer. What is meant by the term asymmetric centre? Well, it's simply a carbon surrounded by 4 different groups. And then explain in terms of structure the meaning of the term optical isomers. Again, non-superimposable mirror image enantiomers which rotate plane polarized light in opposite directions. Draw the displayed formula of the structural isomer of C4H9OH, which contains an asymmetric centre. So it can't have the OH at the end, it has to be on one of the middle carbons. So here we have C2H5 and OH, a CH3 and a hydrogen. So the chiral carbon there is marked with the asterisk. Then the 2 optical isomers of the molecules identified, well again just drawn those 4 groups. There's the hydroxide, the methyl, the hydrogen, and the C2H5, and then the mirror image over here. Then how can a solution of one optical isomer be distinguished from a solution of another? Well, it's simple. You put plane polarized light through it, and then you record the degree of rotation for each isomer, or you could say that they will rotate in opposite directions. Okay, thank you.